So today we're starting function notation. Now, what are we doing today? We're going to understand functions, points, and their use. You know what we understand? We'll find points from basically function calculations, and we'll find that this stuff is not as hard as it looks. Now, let's talk quickly about the key concepts of functions. A function is just another way to represent the equation of a function, right? Now, when we're using a function, you want to imagine if you had the line y equals 2x minus 3. And what we would do is we turn it into this compact form, because what it allows us to do is it allows us to say what our point is for this function. You'll see what I mean by that in a few minutes. Now, what we need to do now is we're going to talk about the rest of this. When you talk about function notation, we use it because it shows us what our x and our y for our points are. And the only way that we can really understand that is by doing. Now, imagine if I was looking at some function that basically combined height and time. Height was our dependent variable and t was like our x variable, our independent variable. So I could say, I know what my height is at specific time t. So let's go and take a look at that, and I'll give you an example of what we have for this equation right here. So imagine we have this equation, f of x is equal to 2x minus 3, and we want to find f at 4. Okay? What we do is we're going to write our equation to start. F of x is equal to, well, 2x minus 3. Now, when we go and substitute 4 in, we replace all our x's with the number 4. Now, when we do our substitutions, everywhere else except for the fx part, you're going to have to put your substitutions in brackets. So we get f of 4 is equal to 2 times 4 minus 3, which is 8 minus 3, which is 5. So we end up with f of 4 equaling 5. Now, if I was taking a look at this, I would tell you, if I could tell you right now that I know what the point is for this equation, if I want the value when x is 4, it's basically telling me the point is this. For our function is going to be, well, 4, 5. So basically, the 4 comes from the bracketed portion of the f function, because we choose that, and then the 5 comes from our computation on the right side of the equation. Now, let's move on to our next problem. We're going to do another quick point calculation for our first two problems in our next example. So now, remember, we have these things called quadratics. This is a quadratic because its highest power is x squared. Now, we want to calculate all these different numbers. When x is 6, when x is negative 3, when x is 0, and when x is 2x. So let's just do our substitution. Now what I tend to do is I tend to put my brackets for where x is going to be. And then once I've done that, then I do my straight substitution. So 6 goes in this bracket, 6 goes in this bracket, and then we end up with, well, 6 squared is 36. It's just 6 times 6 is just 36. And because we've done the full calculation, there's no brackets left. Now, minus 6 times 6 gives us, well, negative 18. And because we multiplied it through using our waterfall method, basically it just disappeared. The brackets disappeared. And then we have plus 7. So our final answer, when we add them all up, f of 6 is going to be just 25. Now, if I asked you what the point was for this, the point for this value is, therefore, the point is 625 based on our function notation. Let's compute f of -3. It's exactly the same as before. Try it out, and then I'll show you the solution. Now, can you tell me what the point is? Pause and tell me. Here we go. Therefore, the point is -325. We're perfect. For this next one, f of 0, we're going to follow the same rules, but now we're just going to go fast. We're going to immediately start putting brackets for our substitutions from now on. So if I have f of 0, I look at my equation, x squared is going to be 0, so I put a bracket 0 squared. Well, minus 3 times, well, 0 plus 7. So now we have 0 squared is 0, minus 0 plus 7. Therefore, when we add them all up, we end up with f of 0 equaling +7. We'll just put a bracket around this. We're not going to compute the points from now on. You should understand how to do that. So now, let's go and take a look at 2x. Now, anytime I see a variable inside the f of something, I always go and take my time and put my brackets and go back to my first principles. -3 bracket plus 7. And so now we'll put in our substituted values. Now, let's put a big note here. You should realize that 2x squared is the same as 2x times 2x. Now, because it's just straight multiplication, the 2's multiply to end up being 4, and the x's multiply together to give us x squared. So now, this portion here is going to end up being, well, equal to 4x squared, and then minus 3 times 2x is going to be minus 6x plus 7. So therefore, f of 2x is just this value here. Now, if there was any simplification to do, I would expect you to collect all your like terms and order your variables from highest power, x squared, all the way down to our constant. Moving on to our next problem. This next problem is very similar to what we were doing before. The first problem I'll show you how to do. G of -7, we'll quickly substitute. Well, that's -5, and I look for negatives wherever x is, I replace with a bracketed -7, and then plus 8. So -5 times -7 is going to be positive 35 plus 8, and so therefore G of 7 is equal to 43. You'll notice that I don't tend to put anything on the left side after I've stated what I'm doing for my equation set. I go to the very end, and when I'm at the very end, I state my final answer. Now, for G of -2m, let's follow the same rules that we were doing before. When we have a difficult thing, we basically put our brackets in, plus 8, and I'll put -2m. Now, -5 times -2m is going to be basically 10m plus 8. And there's no more simplification to do, so G of -2m is simply m plus 8. Now remember, if there was any possibility of simplification, you would have to do it, or collecting like terms. Now, let's begin. For g of 2x minus 3, we write the following. Negative 5 bracket plus 8. We do our substitution, 2x minus 3. Then we go and, you guessed it, we apply distribution to each of the terms in here. Now, negative 5 times 2x is just going to be equal to negative 10x. Negative 5 times negative 3 ends up being positive 15 plus 8. Now, we must collect like terms here. Because 10x has no variables, we just leave it, negative 10x. But we have 15 and 8. 15 plus 8 gives us 23. And we're going to put plus 23. So therefore, g of x, g of 2x minus 3 is just equal to this final simplified form. So you'll notice with this problem, I did this part here. We call this distribution. Now, you're going to do the same thing for the next problem. Just pause the video and then I'll write the solution. And there you have it. Your homework for the day is these questions that we have in the bottom corner. Page 21, 1 to 3, 6ABE, 7, 8AB. Good luck.